In this video, we will see how a retail business uses IBM's decision optimization capabilities to find an optimum solution for assigning staff in its stores. IBM's data science experience gives us access to these decision optimization engines. The scenario here is the retail business has several stores. The store have different departments and they operate in multiple shifts. Their staff have different skill levels, pay rates, teaming preferences, and their availability varies over a period of time. The business challenge here is to find a optimized staffing assignment. To achieve that, we first need to define the business problem as a mathematical model. As part of the problem definition, we need to specify three things. First, we specify the business decisions we are trying to optimize. In this use case, it is all about staff assignments, deciding which staff member is getting assigned to which department, which shift, and for how many working hours. Next, we specify the business constraints to which the solution has to comply with. For example, in the retail business, in constraints 2, we specify assigned hours should always be less than the maximum permitted limit. Similarly, in constraint 6 in here, we specify assigned staff should always have skills that match their assigned departments. Finally, we specify the business objectives we are trying to achieve. We want to achieve a fair distribution of work hours while minimizing the number of assignments for each staff member and also optimizing the costs. Once the mathematical model is fully defined, we invoke the optimization engines to solve it. By visualizing the results, we can see for each staff member, the assigned hours, the assigned department for each shift, and also we can see that these working hours are centered around an average of 40 hours. Further, for each department, I can see the maximum number of staff members assigned, and this is based on the projected demand for those products. However, when I take a closer look at the distribution of hours, I can see a few outliers here. Two staff members got assigned way below the average work hours, and this is not a desirable situation for the business. So I will refine the business objective. I'm going to define fairness in this iteration as a quadratic expression instead of a linear expression. Unlike linear objectives where the individual outliers are not caught when the mean error is small, with a quadratic objective, you can always confine these outliers. Once the model is redefined, we can invoke the optimization engines again. This generates a new set of assignments. Here are the visualized results. We can see the new staff assignments averaging around 36 to 38 hours. If I compare the two solutions, I can see the assigned hours below the average level are very evenly distributed across the staff for solution 2 in blue compared to solution 1 in red. Through our iterative approach using IBM decision optimization engines, we have now achieved an optimized assignment of staffs.